So in this tutorial we're going to look at a couple or three things you can do when you're given coordinates. Coordinates are of course sort of x, y and are plotted on a normal xy graph, and we're going to deal with 2 points, x1, y1 and x2, y2 and possibly x3, y3, but we'll just deal with those two to start with. One thing you might be asked to do, either just by itself or when you're trying to find the equation of a straight line, is find the gradient of a line segment or a line joining 2 points. And your basic rule is that gradient is rise over run. Some people call it up over across, and it's how steep the line is. And the formula for it is you find the difference in the y coordinates, so you do y2 minus y1, and you divide by the difference in the x coordinates. If you think about that, that is just rise over run. And the only thing to remember is that you must do it the same way around. So if you do the second point minus the first point for the y's, you must do the same for the x's. Another thing you might be asked to do is to find the midpoint of a line segment, and that is the way to remember it is that it's really in the middle. It's the average point or the mean point, and so we simply find the average of the x coordinates, x1 plus x2 over 2, and the average of the y coordinates, y1 plus y2 over 2. And then the difficult thing you might be asked to do is show that 3 points, A, B and C, lie on a straight line. And the way to do that is to find the gradient of AB and the gradient of AC and make them equal to each other. You may just be asked to show they lie on a straight line, or you may be asked to use that fact. Either way, the gradient of AB and AC are equal. And as ever with these sorts of questions, if you're not sure what's going on, sketch it and it might give you a better idea. So let's have a look at question 1 over here. We're given 2 points, P minus 2, 3, and Q 2 minus 5. And we're asked to find, first of all, the gradient of the line segment, and then the coordinates of the midpoint. So let's label up our points. We'll choose P to be x1, y1, so x1 will be 2, and y1 will be 3. And then let's do the same for Q, but with x2 and y2. And now we're good just to use the formulae. As I say, you can remember these things either as formulae or just in more general terms. So the gradient of PQ is equal to, well, looking at the formula, rise over run, or difference in the y coordinates over the difference in the x coordinates. And making sure I subtract the same way, I'm going to do minus 5 minus 3, so that's Q minus P for the y's, and 2 minus minus 2, which is x2 minus x1, or x minus x for Q minus P again. And so let's deal with this carefully. We've got lots of minus signs. Take away 5, take away 3, we take away 8. And on the bottom, we've got the 2 minus signs together, so a minus times a minus is a plus, and that's 2 plus 2, which is 4. And minus 8 over 4 is minus 2. So we do need to be careful of the negative signs here. Right, what about the coordinates of the midpoint of PQ? Well, the midpoint, the middle point, the average point, so we just find the average of the x's and the average of the y's. So let's do that. Write down what we're doing. Midpoint, we don't tend to do midpoint equals, so just write down midpoint and then the coordinates. And it is minus 2 plus 2 over 2, that's the average of the x's, and then the average of the y's. So y1 plus y2 over 2. And again, just being careful with our minus signs, we see that this is 0 over 2, minus 2 plus 2 is 0, and then 3 plus minus 5 is just 3 take away 5, so that's minus 2 over 2, and that is therefore 0 minus 1, and that's the midpoint. Had we sketched that, we'd see that that was roughly in the right place, but we're not going to. Right, let's have a look at a slightly harder question. This time we're given 3 points, minus 2, 10, 1, 1, and 7, y. So there's an unknown here, which presumably we're going to have to find. And sure enough, we're told that they lie on a straight line, and we're asked to find the value of y. Well, we're just going to use the fact that the gradients of AB and AC must be equal. So let's find those two things. Let's find the gradient of AB. Now, good idea to label up our points again as we did in the first question. Let's call A x1, y1. Let's call B x2, y2. And it's not a great stretch to call C x3, y3. Okay, or we could call it x2, y2 again if you really wanted to, but I've called it x3, y3. So the gradient of AB is, again, subtract the y's, 1 minus 10, and subtract the x's, 1 minus 2, making sure we've done it B minus A each time. And that is minus 9 on the top, and again we've got a minus minus, so 1 plus 2 is 3, and minus 9 over 3 is minus 3. Now what about the gradient of AC? That's the other thing we need to find. And so we can say, right, this time it's y3 minus y1, so that's y minus 10 over 7 minus 2. Not a lot I can do with the y minus 10, so we'll leave that as it is. But 7 take away minus 2 is 7 plus 2, which is 9. And we'll just leave it like that. Now, as I say, we're told that they lie on a straight line. So let's write down what we're going to use. So we can say straight line. That's not how you spell straight. That's how you spell straight. Straight line. So the gradient of AC equals the gradient of AB. And that gives me y minus 10 over 9 is equal to minus 3. And so how do we get rid of the fraction? We multiply both sides by 9 and get the green cancelling pen out. The 9's cancel on the left, and that gives me y minus 10 is equal to minus 27. And then to get the y on its own, we add 10 to both sides, like so, and we get y equals minus 17. And that is that. So as I say, 3 things we can do. Find the gradient, up over across, rise over run, difference in the y's over the difference in the x's. We can find the average point, otherwise known as the midpoint, and we can use the fact that A, B and C lie on a straight line. And that's equivalent to saying AB and AC have the same gradient. I hope that helps.